Good morning, everybody. So today we're going to start our first proper lesson, and we're just going to do a review over the whole plate tectonic unit, just a way to kind of make sure everybody's on the same page still, and kind of get our heads back into the groove of learning. So if you take your notes out, I highly recommend that you have your notes out while you listen to this video, or else I'm not going to make any sense. And hopefully if you have the notes, I'll make some sense. So pause the video now and grab your notes out, or grab the notes that I posted on the Google Classroom. So plate tectonic review. The first thing I have here is a slice of Earth. So you're trying at the bottom, we have the center of Earth, and we move up. Now the distances I have here is the distance from the center, or from the core, the crust of Earth, so the top of Earth, so where we stand, to the center of Earth. So the radius of the Earth is about 6,400 kilometers, so that would be like the center here. So I'm going to start from the bottom up. So if we look at the inner core first. Now the inner core is going to be a very hot, the hottest part of Earth, and it's going to be solid, due to the pressure of all the stuff above it. So it's kind of like if you go diving, there's pressure from the water above you. Just imagine that times like a million or times a billion, because it's just so much mass on top of the center of the Earth. All that pressure makes it a solid. And this is actually where we get the magnetic field, or Earth's magnetic field is from the core, the center of Earth. So if we move out about 1,300 kilometers, we reach the outer core. Now the outer core, there's not as much pressure. So here it's still very hot, but we have liquid iron, liquid rock. Everything's just like molten hot, super hot, and liquid. Then we move up to the mantle. Here things cool down a little bit to about 100,000 degrees Celsius. So here we still have molten rock. And the bottom of the mantle, where the outer core ends, is going to be hotter than the top of the mantle where the lithosphere begins. So the heat on the bottom of the mantle heats up parts of the mantle, and as you heat up, you rise. So these parts of the mantle rise up, and then they cool, and they fall back down. And they heat up, rise, and cool, and fall. So this is what we call convection current. As it heats up, it rises. As it cools, it falls down. So these convection currents in the mantle, this is what moves the plates. So this convection current in the mantle is what causes plate tectonics, which is the movement of Earth's crust. So we look at the lithosphere, which is Earth's crust. It's a solid layer, also called the crust. This layer is not hot. It's the Earth we stand on today. It's room temperature, or like temperature of the atmosphere, or temperature like that day. And this layer contains two different types of plates. So we have our continental plates. These are the plates we stand on, and our oceanic plates, these are the plates that are covered in water, ocean. So that's kind of the overview of Earth. Now, if we look into the plates a bit closer, we can see that the oceanic plates, they're going to be younger and denser plates. So they're heavier, and they're younger because they get recycled, which we'll talk more about later on. So the plates get recycled when they collide with other plates. Continental plates are much older. These plates do not get recycled. So the continental plates we have today were the same continental plates we had at the beginning of Earth when the plates first formed. So Earth formed, and it took about 1 billion years for things to cool down, and that's when we got our first plates. And these plates have stayed the same. They change in shape, but it's the same material. So we find the oldest rocks on the continental plates. And these plates are less dense. They kind of float better, if you can imagine a massive plate floating. So, moving into plate collisions, let's first focus on continental and continental plate collisions. So we have the three types of faults when we have these plate collisions. We first have a normal fault, which I thought was a reverse fault for a second. To my mistake, which is why I have it crossed out. So a normal fault, these when two plates are being pushed away from each other. So they're pulling away from each other, and that center bit of land is just going to fall down into that hole that these two plates are creating by coming apart. So we can see there's two fault lines. Generally there's two fault lines. Sometimes there may just be one fault line. And these two fault lines is just where the land's separating as these two plates come apart, and that middle part is going to fall down. The outcomes from a normal fault are going to be earthquakes. As the plates move, the earth can shake. Block mountain or trenches. So these form as that center part falls in. We get block mountains, which are mountains with like very straight edges, like sheer edges, and trenches, where it's just like holes in the ground. And landslides. So as the plates move apart, if the land is not very stable, the land can kind of fall in on itself.